Hi everyone. In today's challenge, we are going to solve this problem. The problem name is shortest path to get all keys, and the problem number is 864. Alright, guys. So as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. What is the logic to solve this problem? And after that, we are going to move to the implementation part. We are going to implement our logic in Python and C++ programming language. Fine, guys. Now let's see what this problem is. Right. So problem says you are given an m cross n grid. Grid. So guys, first thing is clear that we are given one grid, right? The size is going to be m cross n, and where dot is an empty cell. Inside a grid, if we have a dot character, that is nothing but called an empty cell. Hash symbol is a wall, and at the rate symbol is a starting point, right? Lowercase letter represent keys, and uppercase letter represent lowers. Fine. So we are given a grid, and inside these characters, they have given what is the correct role of each character, right? So let's take example of a grid, right? So let's say I have this grid where I have dot at the rate hash, then hash, and then we can say this is again a string where we have dot hash, and here let's say a, right? And here let's say small a. So guys, here you can see this dot is nothing but we can say this is an empty cell. This is starting point. The we are going to start from this particular cell. This is wall, and this is small we can say lowercase character. So this is nothing but we can say a key, right? Then there is nothing but again a dot, that means again a empty cell, again empty cell, wall. Then this is a low, right? I hope it makes sense. This is a low and this is a key, right? Now guys, let's see. Here they say you start at the starting point, and one move consists of walking one space in one of the four cardinal directions. So simple guys, we if we are standing here, so we can move four directions, right? Here and here. If this is a matrix, so we can move upside, left side, right side, and downside, right? You cannot walk outside the grid or walk into a wall. So we cannot move outside of the grid. That means we cannot move outside of matrix, and also we cannot move. We can say this particular wall, right? We cannot move over this particular wall. So that's clear. If you walk over a key, you can pick it up, and you cannot walk over a globe unless you have its corresponding key. So guys, let's see with the example, right? Simple. So what I'm going to do, I'm going to say guys, here you can see if we have, we can move to empty cell, right? We cannot walk into this particular wall, or we cannot walk outside of grid, right? And also if we have a key, right? Let's say we are walking these directions and we got a key, right? So we can pick this key, and key always represent with a lowercase character, right? So we can pick this key. Now whenever we are finding a low, let's say we found this low, right? So we cannot pass into this particular we can say cell until and unless we don't have its corresponding key. So you can see this is a white color in this image, so that means we need a white color key, right? So you can see that we have a key already, so we can walk into this, right? But if the same case comes like this, here and here, if we move this direction, so you can see that we have picked a white color key, but we are facing this particular yellow color low, right? So we need to have a yellow color key, right? So until and unless we don't have key, we cannot pass this. This will act like a wall until and unless we don't have key corresponding to this particular loop, right? So this is the meaning of this particular line. After that, for some k 1 to less than 6, there is exactly one lowercase and one uppercase letter of the first k letters of the English alphabet in the grid. This means that there is exactly one key for each log and one log for each key. And also that letter used to represent the key and logs were chosen in the same order as the English alphabet. So the simple thing guys, we always gonna have this a, small b, small c, small d, small e, f, and this a, b, c, d, e, and f, right? So these are the six characters, and this also the six characters, right? These are six lowercase, these are six uppercase. So these can be the key, and this can be the log, right? So if a problem have we can say three keys, right? Or we can say three log, so they will always gonna have inside in between of these character, right? We cannot have more than six log in a particular problem, and we can have only the logs which are present in this particular first six character, right? Let's say this white log represent a, so we are going to have here nothing but a. You can see in the example as well, a, right? So the corresponding key always going to be small a, right? Remember this thing. If we have a c, then corresponding key always going to be small c, right? If a particular, we can say this particular grid contain a capital C, then it must contain a small c to unlock this particular thing, right? I hope it makes sense. So this was the basically meaning of this particular para. Last thing is nothing but return the lowest number of moves to acquire all the keys. If it is impossible, return -1. So guys, the main possible goal for us in this problem is nothing but we have to acquire all the keys. Here you can see we have two keys, right? So we have to take all the keys, right? So here we can do this particular path, right? So if you will focus 2, 4, 6, and 8, we need this 8 number of cell we need to traverse, and we can easily get all the keys, right? There are only two keys, so we can easily get two keys. Simple logic, guys. Not logic, simple problem, right? So I hope we have understood the problem statement. Now let's see the examples. So the first example is nothing but we have seen, like how we are going to move. We are going to move like this, and we are going to get answer 8, right? So the next example is nothing but this. We need to find this two key, means we need to acquire all the keys. So we can say like move to these directions, and you can get like this, right? So you can see 1, 2, 3, 4, 5, 6. So you can see answer is nothing but 6 only, right? And here in this example, you need to acquire all the keys. Here is only one key, so we need to acquire this one. So we cannot go like this, we cannot go like this. We have to go like this only. But here you can see we are getting ahead key or loop, right? So to pass this loop, we need to find we need to have this corresponding key, but we don't have initially anything, right? So we cannot pass until and unless we don't have key. So we could not able to pass there, and so we could not get this particular key, right? So we are going to return -1. We could not able to acquire all the keys. Simple problem statement, right? I hope you understood the problem statement and the examples, all right? Now let's move to the logic part and see how we can solve this problem, right? And logic is going to be really fun, guys, because nothing we need to do, simple algorithm, right? So first of all, the algorithm here it says, or not algorithm, problem says return the lowest number of moves. So guys, just tell me, if we have a something like this grid or matrix or graph, and wherever we need to find a minimum number of moves, minimum number, shortest distance, anything, right? So which algorithm we use? Definitely we use a BFS, right? Breadth first search, right? Right. It is very efficient to find a minimum number of moves, right? Or minimum number of paths, anything else, right? So what we can do now, guys, here we are going to use a BFS, but in a slightly different way, because here we have three more conditions. The first condition is we cannot move into the wall. Second condition is we cannot pass to the key. We cannot move to this particular key, or we cannot pass this particular low until unless we don't have that respective key, right? So we have to check this condition as well in this PFS. The third condition which we are going to see is this, guys. We can move again to again back to this particular cell. There is no restriction that you cannot move to the same cell again, right? We can move to this cell if we come to this, and then we can also go to this. Like again, we can move to this. So that means we cannot use is visited on a particular row and column. We have to use a different way, right? So that means I hope you get this particular point. That means we cannot say that if you have visited only this all, let's say you have visited this 2,0, or you can say 3,0, or anything here, like any cell, right? If let's say you have visited on this particular cell, so what I can say, I can revisit this cell, right? So I hope this makes sense, right? So third condition we need to check, and then we can easily solve this particular problem, right? So first thing is nothing but we have to see how we can handle this particular thing, how we can handle this ball. So that is simple. We can check a condition if grid is equal to hash, so don't move to this cell, right? Second is, let me write here, right? First condition simple, we can check whenever we are moving, we can check if that character is hash, so don't move here. Second, we have to consider this particular we can say cell, right? This particular law, we cannot move past this law, this cell, until unless we have respective this particular respective key, right? So we can say if the character is capital, right? If that character here you can see, if always log will be represented by this first six character, right? If our character in this first six character, we can say first six capital, or we can say uppercase character, so then we can say simple. If this is the case, so what you can do, you can say simple, just check whether we have this corresponding key in our we can say a variable. Let's say the variable is nothing but keys only, right? So we have this particular key smallest. So you will find that if it is the case, then we can easily move this. But if it is not the case, so we can say you cannot move this. So you can try another direction, but you cannot move to this direction, right? Fine, this is the this can be easily solved. Now the third question is we can revisit the cell. So if we can revisit the cell, then how we can stop our recursion? What is the base case, right? How we can stop pushing in our queue, right? So the base could be we can use a particular thing, right? So we can say if you are visiting the same cell, then you must have a different key right now, right? Earlier you were having a two keys. Now if you can revisit this cell, now if you have a three keys, right? Means you have took a benefit of anything from this side, right? If you haven't took, then you can there's no benefit of again revisiting this cell with the same keys, right? So what is the benefit if you could not able to pass all the test cases? Let's say guys you are here, right? And you need to pass this cell, right? And you know that we could not have this by respective keys, right? Fine. And you move to this cells, you traverse all the thing, right? Let's say you could not find this key as well again, and you are coming back, you are traversing again this thing. So what is the benefit of again traversing this, right? Because you will not have a key this. So we can only revisit the cells if we have a changes in our keys, if we got a new key again, right? If we go to a different key, then we can only revisit this. Otherwise, we will not revisit that cell. So we will discuss it how we can handle this particular case. But for now, I just want to make you clear that what are the changes we are going to do in this PFS, right? So first thing, we are going to provide this particular person to pass this wall. Second, we are going to see if we can only pass the this slope until and unless we don't we can have this particular key, right? The third thing is we can only revisit the cell if we have changes in our keys, right? If the keys are also same and we want to revisit the same cell, we will not allow him, right? All right, so these are the three conditions which we are going to use. Now when we are going to return, so fourth condition is nothing but when we are going to return. So guys, we are going to return only when we have all the keys. So we are going to initially use a loop. We are going to find total keys, how many total keys we have, and now in the BFS we are going to check if our total if our collected keys is equal to the total keys, then we are going to return our moves. I hope it makes sense, right? So if it still we can say if it still it is confusing, so don't worry about this part. Let's see the code part, right? In the implementation part, you will have a better understanding. So first of all, let's move to the browser. So guys, here first of all I'm with the Python. So let's write here first of all. What we are gonna do, we are gonna say, okay, so count. We are gonna say count initially 0. We don't have any keys. So let's start over the this grid. So first of all, let's take a length. So length of grid. Let me write a small g. And here we can say length of grid of 0, right? And this is again a same mistake grid, right? Fine. Now once we got a length, so we are going to traverse it for I range of n and for j range of m. Right. Here, if we found grid of I and j is equal to, we can say in, right, in A, B, C, D, F, right. If it is in this characters, right, if grid of I comma j in A, B, C, D, F, that means this is a key, right? So we can say count plus equal to 1. And if grid of I, let me write grid of I and j is equal to at the rate symbol, that means this is our starting point, right? So we can say if it is equal to at the rate symbol, that is our starting point. So we can keep it as code also, starting row and starting column, right? Starting row is always going to be I and starting column is always going to be j, right? Fine, that makes sense, right? Now once this is done, we are going to say okay, now use a BFS. So for BFS we need to maintain a queue. So let's say I make the queue is going to be nothing but collections dot tq, and here we are going to say fine, in this first initial we can say cell is going to be nothing but your start row and start column, and one more thing, that is nothing but keys. So guys, what is the keys right now? We don't have any keys right now whenever we are traversing it, right? So we can say we don't have any keys. Fine. Now we are going to say while this queue exists, I mean while this queue have at least one data, so keep traversing, right? So calculate the size. So q dot, we can say length of queue, and here we are going to say for underscore in range this size, we are going to say fine, we have this size. Now we are going to traversing all these levels. For each level we are going to say first of all take a data. So we can say current row, current column, and we can say one more thing, that is nothing but keys, right? So that is going to come by come from q dot pop left, right? Pop left. I hope it makes sense, right? Now we have current row, current column, and keys, right? Now first of all, what are the base condition we have set? We have set if key is length, if length of keys is equal to our count, that means we have already collected all the keys, so return that particular moves. So we haven't defined a moves yet. So let's say moves initially is 0, right? So we are going to return moves. But if it is not the case, then we are going to check one more thing. We need to revisit this particular cell again? So this will be decided by our one, we can set, that is nothing but is visited, right? Is visited is going to be nothing but set. So we are going to say if this cell, we can say CR, current column, current row, current column, and keys in already in our is visited set, so we don't want to revisit again, continue. But if it is not the case, so is visited dot add, you have to add this particular current row, current column, and keys. Simple thing, right? Fine. Now we are going to say move to the all four directions, right? So four direction is going to be nothing but direction is going to be nothing but we can say for x comma y in 0 comma 1, 1 comma 0, and 0 comma minus 1, minus 1 comma 0, right? Fine. Now here we have to get a new row and new column. New row is going to be nothing but current row plus x, and we can say, let me write here new column as well. New column, current column plus y, right? Now once we got a new row and new column, we have to check first of all. New row should not be less than 0, or new row should not be great. New column should not be less than 0, or new row is greater than equal to n, or new column is greater than equal to m, or we can say grid of new row and new column is equal to hash. So if any of these conditions satisfy, that means this is not a valid, right? So we can say continue. Fine. And if it is not the case, then we are going to check some condition. First of all, let's say we have this character, right? So character is going to be nothing but new. grid of new row and new column, right? Now we are going to check if this character, we can say if it is in upper, right? So if it is in A, B, C, D, E, F, right? If it is in this particular characters, and we can say if this character in this, if this character is in either A or B, C, D, E, F, or, and not or, we have to check also. If we found this, that means this is low, right? We are currently standing on the cell which is a low. Now what we can do, we can say if we have a key respective to this, then only we can move this, right? So, and we can say if, and character dot lower, which is going to convert into lowercase in our keys. This is a product keys, right? We have already fetch out when we did a pop left, right? So if it is in our this keys, that means we have already keys, right? So what is this happening? Okay, so we have already this keys, right? So what we can do, we can say simply you can pass this particular cell as well. So we can say q dot, right? Q dot, we can say append this particular current row, current column, not current row, new row, new column. So let me write a new column, and here we have to say keys will gonna remain same, right? And one more condition, else elif, right? Elif char, if this char in our dot or at the rate, right? So we can say if dot or at the rate, that means this is an empty cell, right? So we can traverse it here as well. Q dot append, and here we can pass same thing, new row, new column, keys, right? And note these things. And last condition is elif char in our, if char in our small a, small b, c, d, e, f, right? If it is in these characters, right, that means this is a key, so we have to pick this key, but only when we don't have this key, right? So we can say if this char in our keys, then we don't need to pick this, right? If this in our keys, so we don't need to pick this. We can simply say just copy these things, so we can simply paste it over here, right? Okay, so this is gonna make a changes, right? So we can do like this. If it is in not in our key, if it is in our key, then we have to do this. Our, if we this is not in our key, right? If we don't have already collected this key, so we have to collect this one, right? So we can say q dot append new row, new column, and here we have to say key keys plus this particular character. That means we have already now collected this particular key, right? Once this is done, we are going to say fine. After this for loops, you have to implement your move plus equal to 1, and then this in this while, after this while loop, we have to return -1. Why? Because if it is possible to collect all the keys, then this condition will always gonna run, right? Otherwise we have to return -1, right? Let's see and whether it's working fine or not. And we don't want to see any error. Let's see, right? So we got an error that is nothing but grid, right? So again the same mistake, grid. Now let's see any more error. Okay, one more error, ch does not define, right? Ch is not defined. Why? Because we have char, right? Let's see. You can see, guys, all the test case passed finally. So let's try to submit this code, right? So by this we have successfully submitted with a Python, right? Let's see whether it's get submitted or not. And it's successfully got submitted. So we have successfully submitted with a Python programming language. Now let's move to the last programming language, C++. And I'm doing this just because time is gonna really too long. This video will be more than 30 minutes then if I started implementing with JavaScript and Java programming language. But believe me, guys, I believe if you have understood the logic part and this implementation part, you will definitely implement in your programming language as well, right? So now let's move to this C++, and here what we are going to do, first of all, we are going to say calculate the length of grid, sort size, m is going to nothing grid of 0 dot size, and here we can say first of all we can say start row, and here we can say start column, which is we will calculate it, and we are going to say count as well, right? Count is equal to 0 initially, means there is no keys we have currently, right? So we are going to say for int I is equal to 0, I less than n, I plus plus small n, I plus plus. Here we are going to say for int j is equal to 0, j less than n, m j plus plus. What is happening? Fine. So we can say if grid of I and j, right? If it is the case, is equal to 0. If it is equal, not 0, if we can say if it is equal to at that symbol, which means this is starting point. So we can say start row is going to be equal to I and start column is equal to j, right? And if grid of I is equal to, we can say if it is equal to this upper small case character, right? So that means if it is greater than or equal to a, and we can say not this and we have to use this and operator, grade of I and j is less than equal to f, right? If it is the case, then this is a key, right? So we have to increment our count. Now we, by this loop, we know that how many keys are present and how many keys we need to collect, right? And what is our starting point. So we're going to define our q. So we can say q. Let's say write q, and let's say here that we can say what is the gonna be. Q is gonna be have a vector. So we can say vector. Fine. And here not vector, we can use a pair, right? Why? Because we need to store different data types, right? So we can say pair. And here inside of pair, we are also going to have one more pair. This pair is going to contain nothing but row and column, right? I hope it makes sense. And next, nothing but is going to contain string, which is nothing but keys, right? Fine. And so we have to close this. Now we can say name is q. Now q dot push. What we are going to push? We are going to push first of all start row, start column. So guys, this is nothing but we can say first thing, right? Which is where we are going to start it. The second thing is nothing but keys. So initially we have empty keys, right? So guys, I hope you are getting this particular part. What we are doing. So we are nothing but we are using a two pairs, pair inside a pair. So there we are in first pair we are going to have start row and start column, and the second pair we are going to have nothing but the keys, total keys. So we have no key right now, right? After that we are going to define a set is visited. So is visited going to be set. So we can say unordered set, and the data type is going to be string, and here we can say is visited. Fine. Now after that what we are going to do, we are going to define one more thing, that is moves, right? We have initially 0 moves. Fine. Now let's move start a bfs. So while q dot empty, right? So you have to keep traverse here. First of all find a size. So we can say length length q dot size, and here let me add a size, right? And here we are going to say for int I is equal to 0, I less than length like plus plus, right? And here we are going to pop out first of we can say the front element, right? So we can say auto data is going to be nothing but q dot front, and same after that we are going to say q dot pop, right? Now we are going to say our current row is going to be nothing but data of 0, current column is nothing but data of 1. Fine. And not data of 0, data of 1, we don't need to use this because we are using a pair now. So we can say data dot first is going to contain both things, row and column, right? So dot first is going to be nothing but row, and current column is going to be nothing data dot first dot second, right? Fine. And our keys, string keys, is going to be nothing but data dot second, not data dot second, right? This is going to be our keys. Fine. Now we have to also make one key which is used for our is visited, right? Do we need to visit this cell again and anymore, right? So for that we are going to say this is going to be nothing but to string, and here we are going to use a current row. Then we are going to use this colon plus to string. We are going to use current column, then plus, then colon, plus we have to use nothing but keys, right? So this is nothing but going to make a unique key every time for this cell, right? So we are going to check if is visited. So we can say if is visited, but find this key. If you are not able to find it, then cool. If you are able to find it, then we can say is visited dot end. If it is equal to this end, if it is not equal to this end, that means you are well able to find it, right? So we can say continue this. We don't want to traverse it, right? But if it is not the case, so you have to add first of all is visited dot insert. You have to insert this key. I hope it makes sense, right? Now once we are done this, we are going to check one more condition before this. Before this ahead, we are going to check if key dot size is equal to count, then what you are going to do, you are going to say return moves, right? This is our base condition, right? So if we have already all the keys, right? If we collected all the keys, then we are going to say return that number of moves. Fine. Now once this is done, so we are going to move to the old directions. Let's define all the direction. First of all, vector in direction is going to be nothing but 0, 1, 0, -1, and here we are going to say 1, 0, and here -1, 0, right? Now we are going to say for int I is equal to 0, I less than n, not n, I less than 4, I plus plus, right? And here we are going to say int new row is going to be nothing but current row plus direction of I and 0, right? And new column is going to be nothing but we can say current column plus direction of I and 1, right? After that we are going to check if it is out of bound or not, right? If new row is less than 0, or new column is less than 0, or new row is greater than or equal to n, or new column is greater than equal to m, right? And last thing is nothing but grid of, we can say grid of I and j. If not I and j, new row and new column, right? Not I and j. If it is equal to, if it is new row and new column, if it is equal to hash, so that is also invalid. If any of these conditions satisfy, so we can say continue this thing, right? Fine. Now once this is come out, if we could not find any of these conditions true, so we are going to come out this line, and here we are going to say if first of all take a character. So char ch is going to be nothing but grid of new row and new column. Now we can say if this ch is greater than a, not greater, equal to as well, right? If it is greater than or equal to a and ch less than or equal to our let me write this, less than or equal to our, we can say f, right? That means this is a log, right? And we can only move this log if we have a key, right, respective to that key, right? So we can say present, and we are going to pass the ch plus 32 and comma this particular keys, right? So why this is a function, we are going to define this, but first of all let's define this function only, right? So guys, we are going to say here bool and present, and here we're going to say first of all character, then we are going to take a string keys, and we are going to say here in this function you have to traverse for int I is equal to 0, I less than keys dot size I plus plus, right? Here we are going to say if keys dot I is equal to ch, so directly return true. But if it is not the case, so what you are going to return, you are going to return nothing but false, right? So you are going to return nothing but false. So I hope it makes sense, right? And here once this is also done, so we are going to say present. So this guys, this function, what this function going to do is this function going to say ch plus 32, right? So ch plus 32 means nothing but we have this character uppercase. Now we want to check if the small lowercase character, same lowercase character is present in our keys or not, right? So the lowercase character is nothing but ASCII value. If we add 32 in ASCII value of ch, then that will become a lowercase character. So by this we are making this lowercase character and we are checking it. If this is present in our keys, then we have to return true, otherwise we have to return false. I hope it makes sense, right? So if it is the case, if it is present, so we can move to this particular cell. So we are going to say q dot push. So we are going to push nothing but new row, new column, and we can say this particular keys, right? Keys remain same. And one more condition, else if ch is either equal to this store or ch is equal to this at that symbol, then also we can move it, right? So we are going to copy this particular thing and we're going to paste it here, right? And one more condition, else if, that is if ch is smaller, right? If it is a key, so if it is less than, not less than, greater than or equal to the small a, or we can say and operator ch is less than or equal to small f, right? That means this is a key. Now if we need to pick this or not, we have to check it, right? If present of this ch comma key, if this is the case, if it is present, then we don't need to pick it, right? So we can say simply call this function, right? Else we gonna say else we have to pick this key. So for picking we have to add into it, right? So we can say keys plus ch. Fine. And once this for loop over, so we are gonna say not this for loop, this one for loop, right? So once this for loop over, so we are gonna say moves plus plus, right? And here we are gonna say nothing but return -1 if it is not present, right? If we could not able to collect all the keys, so we are going to come out this while loop and we are going to return -1. Now let's see whether it's working fine or not. So we got a first error, if case ch is equal to 2, we have used a Python programming language here. So what I'm going to do here, fine. Now let's see whether it's working fine or not. So let's check this thing. And we got an error that grid dot size comma this undeclared identify grid. Again the same mistake, we have using a grid small r. Where we have used this, we have used in first line only GIRD. Not this should be GRID, right? Let's see now. We are doing a lot of mistake, right? And I hope we should not have one, but still again key dot, we don't have key, right? We have keys, right? I don't know why I'm doing keep doing this all mistakes. So do we have any more things? String keys. So here we are declaring redeclaring keys. So we don't need to do like this. Why? Let's check this. Keys declare here, not key declare here. Okay. Now we don't have push, use dot operator. Cannot use dot operator on a type, right? Q use cannot use a dot operator. Why it is the case, right? So this is the case, right? So we can say q dot push, right? So we can push it, right? This is a q. Let's see the q. We have okay. This is small q, right? Not a capital Q. Let's see q and again a q and again a q. A very silly mistake in C++. I really don't find this. And while popping, we are using a small q only, right? Let's see now whether it's working fine or not. So you can see, guys, all the test case passed, right? So let's try to submit this code as well. Finally, it should get submitted, right? I hope. All right, so Let's see. Here we go, guys. Right. So finally, we have successfully submitted with C++ as well. So, guys, I now will suggest you that try implementing in your programming language as well. If you are using a JavaScript or because Java or any other programming language. But yeah, I believe that by this implementation part, Python and C++, and the logic and problem understanding part, you must have a better understanding what you have to do now, right? So if you have learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet in the next video.